Page number 51, Unit 4. Ocean relief features and salinity of seawater. Unit structure 4.1. Objectives 4.2. Introduction to ocean morphology. 4.3. Ocean morphology. 4.4. Bottom relief features of the Pacific Ocean. 4.5. Introduction to salinity of ocean. 4.6. World's distribution of salinity. 4.7. Conclusion. 4.8. Questions. 4.1 Objectives: to study the morphology of ocean, to study the distribution of relief features in Pacific Ocean, to study the salinity of seawater, to understand the factors responsible for variation in salinity of seawater, to study the distribution of salinity of seawater in the world. Introduction 4.2 Introduction to ocean morphology. The configuration of the ocean basin with reference to their nature and various dimensions is known as morphology of oceans. Different marine provinces form the basis of identification of various relief zones of ocean basins. Oceans cover approximately 65.7%, 335 million of square 4.2 Introduction to ocean morphology. The configuration of the ocean basin with reference to their nature and various dimensions is known as morphology of oceans. Different marine provinces form the basis of identification of various relief zones of ocean basins. Oceans cover approximately 65.7%, 335 million square kilometers of surface. Like the land surface, the ocean bottoms represents various kinds of marine features, that is, plain, plateau, ridge, steep, etc. The knowledge about the relief of ocean floors was very limited in the past centuries, but the development of sound recording machine enabled the oceanographers to get more knowledge about the depth and topography of the ocean bottoms. 4.3 Ocean morphology. Hydrometric curve is essentially the graph that shows the proportion of land area that exists at various elevations by plotting relative area against relative height. The hydrographic curve is a scientific way of describing the topography of the seafloor. After the study of hydrographic curve, the ocean and sea bottoms may be demarcated into various relief or depth zones as given below. First, continental shelves. Second, continental slopes. Third, abyssal or deep sea plains. Fourth, ocean deeps. Figure 4.1 Hydrographic curve, a schematic representation. Hypsometric, hydrographic, and biothermic curves of the Earth with configuration of ocean floors. Altitude 0 to 50 with respect to 50 to 100 continental slope, 100 to 300 300 to 400 rise of magma, 400 to 500 ocean floor. Zero to 2 sea being lift velocity on ocean plate. Height of land. Altitude depth. First, continental shelves. Continental shelves represent the shallow part of the ocean and since it extends between low tide level and 100 fathoms depth of the seawater. It is almost uniform zone of sea wade with a gentle gradient with the width of the continental Silts varies from coast to coast depending upon the ground geographical structure and geomorphological nature of the coast. The average width of the continental silts is about 70 kilometers. The continental silts are formed by erosion of coastal area by sea waves. Some continental shelves have been formed by deposition of sediments in the sea brought by the rivers. According to some views, the continental shelves were formed due to change in the sea level or subsidence of coastal land by tectonic movement. The formation of continental shelves is also thought due to emergence of the ocean and sea bottom. The continental shelves have been grouped in the following types on the basis of their formation and location: A. Glaciated shelf, coral reef shelf, C. Riverine shelf, and D. Mountainous shelf. Importance of continental shelves: C. Marine life is abundant due to availability of sunshine. Sunrays penetrate to the depth of the shelf and various kinds of grass, seaweed, weeds, and planktons are available. They are used as food for marine animals. B. Various kinds of minerals like petroleum, natural gas are also found in shelf area. Second, continental slope. Continental slope is the next depth zone of ocean and sea floor to the continental shelf. It begins with outer edge of the shelf where the gradient of slope becomes steeper abruptly. The average slope of this zone is 4 degree, but it varies from place to place. This zone is free from the deposits due to steep slope and about 60% of sediments of continental slopes are mud and the rest is composed of sands, gravels, and organic remains. It covers smaller area of the oceans and seas. There are five types of slopes. A. Fairly steep slope dissected by canyons. B. Gentle slopes with elongated hills and bastions. C. Faulted slopes. D. Slopes with terraces and slopes with seamounts. The origin of continental slopes is still not known, although some may be as a result of large-scale earth movement called plate tectonic. It does not always extend up to deep sea but interrupted by wedges of deposited sediments. The deep waters of the continental slopes are very ideal for catching deep living rockfishes, thorny heads, sabblefishes, and dover sole. Generally, these species are caught as a group. Abyssal plain or deep sea plain. Beyond the continental slope, a broad and featureless deeper part of the ocean is found. This deep plain is known as abyssal plain. The deep sea plain is found between 2,000 to 6,000 meters depth. Gradient of slope is very gentle and it appears as a uniform flat plain without any relief. Moreover, the deep sea plain is found by deposition of sediments of especially marine origins. The abyssal plain exerts significant influence upon ocean carbon cycling, dissolution of calcium carbonate, and atmospheric CO carbon dioxide. Considerations over timescales of 100 to 10,000 years. The structure and function of abyssal ecosystems are strongly influenced by the rate of flux of food to the sea floor and the composition of the material that settles. Ocean deeps. On the ocean bottom, a large number of narrow, elongated, deep depressions have been recorded by the sound recorder device. Their depth is rather greater than the abyssal plain, and some of them reach up to more than 9 kilometers below sea level. The peculiarity of the distribution of the ocean deep is that they do not occur amidst the sea ocean bottom, but along the coast parallel to the fold mountain. Most of the heat from global warming is absorbed by the oceans as it covers 70% of the Earth's surface and therefore has the capacity to absorb heat a thousand times more than the atmosphere. Oceans are thus the main heat sinks of the Earth. Besides the above discussed major relief of the ocean bottom, submarines, canyons, submarine ridges, abyssal hills, sea mount, guyouts, and atolls are also commonly found in the oceans. Fifth, submarine canyons. A long, narrow depression is commonly found on the continental shelves and slopes. These depressions are called as submarine canyons. They are usually perpendicular to the coast. Their profiles resemble V-shaped valley with concave rock wall. There are three groups of canyons on the basis of their location and appearance. One, submarine canyons, which begin from continental shelves and extend to the slopes. Canyons, which are found at the mouth of the rivers and extend up to the continental slopes, and dendritic canyons, which are cut down in many branches. Submarine canyons are diverse and complex in terms of their origins, hydrography, geologic settings, and biodiversity of marine reserves in mainly locations because of their association with higher biomass and biodiversity. Abyssal hills, seamount, and Guyot. Some isolated hills on the bottom of the seas and oceans are called abyssal hills. The abyssal hills attaining height of more than 100,000 meters are called seamounts. Broad and flat-topped seamounts are called guyouts. Atolls, concentric coral reefs, and deep white lagoon are common features in any ocean. 7. Submarine ridges. Like mountain chains on land, a long continuous chain of mountains are also spread out in the mid of the oceans. They are formed longer series of mountains on the earth. 4.4 Bottom relief features of the Pacific Ocean. Pacific Ocean is the largest and deepest ocean of the world. It extends from the Antarctic region in the south to Arctic in the north, on the lying between the continents of Asia and Australia on the west, and North and South America on the east. Pacific Ocean, like the rest of the world's ocean, was formed millions of years ago and has a unique topography. It also plays a significant role in the weather patterns around the globe and in today's economy. The Pacific Ocean has highly varied topography. Oceanic ridges are found in a few places in the Pacific Ocean, and they are the areas where new oceanic crust is being pushed up from below the Earth's surface. The Explorer Ridge lies at the northern extremity of the Pacific Ocean. The John D. Foucault lies west of Vancouver. Continental shelves cover rather less area, while the deep sea plains occupies largest area of ocean bottom. The depth of the sea plains is also greater than that of the sea plains in other oceans. This ocean is associated with a large number of abyssal hills, seamounts, guyards, and plateaus like Albatross near western coast of South America. An abyssal hill is a small hill that rises from the floor of an abyssal plain. The greatest abundance of abyssal hills occurs on the floors of the Pacific Ocean. These Pacific Ocean hills are typically 550 to 300 meters in height, with a width of 2 to 5 kilometers and a length of 10 to 20 kilometers. They may be cratered along the flanks of the East Pacific rise as hots and graben features, and then become stretched out with the passage of time. Nearly half of the world's seamounts are found in the Pacific Ocean. and the rest are distributed mostly across the Atlantic and Indian Oceans. Guyards are the flat-topped seamounts. Thousands of coyotes, often in chains and clusters, are spotted across the western Pacific Ocean, especially between the Hawaiian Islands and Japan. The Pacific Ocean is specifically known for the island hawks and ocean deeps or trenches. Out of 52 known ocean deeps, 32 are found in this ocean. The Pacific is home to the deepest ocean point in the world, the Challenger Deep in the Mariana Trench. This trench is located in the western Pacific to the east of the Mariana Islands, and it reaches a maximum depth of 35,840 feet. Kuril Trench, Tonga Trench, Aleutian Trench, Japan Trench, Tuscarora Deep, etc. are the other important ocean deeps in this ocean. This ocean is exceptionally free from the submarine trenches. The concentration of a large number of reefs and islands hawks from Aleutian Island to New Zealand, although Japan is attributed to the subduction of oceanic plate beneath the Asiatic continental plate along the margin of convergence in Pacific Ocean. The Northern Pacific Ocean and also Northern Hemisphere also has more land in it than the South Pacific. There are many island chains and small islands throughout the ocean. The largest island within the Pacific is the island of New Guinea. Volcanic eruption and earthquakes are very common phenomena in this ocean. The characteristic of the characteristic feature of this ocean are a feeble development of continental shelves, absence of any continuous middle dividing rise, and abundance of dips and trenches. Check your progress. 1. What do you understand by morphology of ocean? 2. With the help of isographic curve, explain different relief features of ocean basin. 3. Explain with the examples of various relief features found in the Pacific Ocean. Salinity of sea water. 4.5 Introduction How to salinity of ocean. Salinity is defined as the ratio between the weight of the dissolved materials and the weight of the sample sea water. Salinity is expressed as gram percentage. Salinity can be measured using the handheld refractometer, hydrometer, or conductivity meter. Salinity of the oceans and seas vary in open seas. Usually, where there is a free mixing of fresh water, the proportion of salinity remains constant. But where free mixing is absent, variation is seen. The average salinity of the seawater is 34.5%. The total amount of salt in seawater is gradually increasing every year. This is because it is brought from the land every year. Dittmar, during his Challenger expedition in 1844, reported the existence of 47 types of salts in seawater. Figure 4.2 Salinity: seawater 1 kg after evaporation, salt 35 grams, so that salinity is 35%. Sources of salinity: first, in areas where the temperature is high, evaporation will be greater, leading to lower dilution of salt. Together with high temperature, if humidity is also low, then salinity will be high. Secondly, in fresh water is continuously added in the form of precipitation, rivers, and ice or icebergs, then the salinity will not be high. The factor controlling salinity in an ocean. First, rate of evaporation. There is a direct positive relationship between the rates of evaporation and salinity. Greater the rate of evaporation, higher is the salinity. The subtropical region has highest salinity. Here the sky is clear for more periods in the year. Land is relatively more in this latitudinal belt, and sources of fresh water supply are relatively low. All this contributes towards higher rates of evaporation and so more salinity in the seawater. Second, precipitation. Higher the precipitation, lower the salinity. Lower the precipitation, higher the salinity. This is the reason why the regions of high rainfall are associated with comparatively lower salinity than the regions of lower rainfall. Third, influence of river water through the rivers bring salt from the land to the ocean. Big and voluminous river pours down the immense volume of fresh water into the seas, and so the salinity is reduced at their months. For example, comparatively low salinity is found near the mouth of the Ganga, the Congo, the Nile, the Amazon, St. Lawrence, etc. The influence of river water is more pronounced in the enclosed seas. For example, Danube River reduces the salinity is Black Sea 18%. 4. Atmospheric pressure and wind direction. Anticyclonic condition with stable air and high pressure increases salinity of the surface of the water oceans. Subtropical high pressure belt represents the scorch conditions to cause high salinity. Wind also helps in the redistribution of the salt in the oceans and seas, as winds drive away saline water to less saline areas, resulting in a decrease of salinity in the former and increase in later. Fifth, circulation of ocean water. Ocean current affects the spatial distribution of salinity by mixing seawater. 4.6, world distribution of salinity. The latitudinal distribution shows that there is a low salinity at the equator, ranging from 24 to 25.5% because of high rainfall and the large number of days with overcast sky. The region between 20 to 40 degrees north and 10 to 30 degrees south are the region of high salinity due to the large number of cloudless days, which increase the heat and promotes evaporation. Sargasso Sea 37%. Yes, it's Brazil, Southeast Brazil 31%, Western Australia 36%, and near Peru, Chile 36.5% are the high salinity zone. After obtaining maximum in the lower middle latitude, salinity again decreases to 31% in the northern hemisphere and 33% in southern hemisphere, that is 40 to 60 degrees north and south. Further poleward salinity decreases due to the melting of ice. The average salinity for northern hemisphere is 84%, while in south it is 35%. This is attributed to the fact that in the south a comparative less of mixing and the less addition of fresh water takes place, and there is absence of land. Salinity either decreases or increases with the depth according to the nature of water mass. Generally, there is a decrease with the increase of depth. At equatorial region of Indian Ocean, salinity increases with depth 34% to 35%. At the southern boundary of the Atlantic surface, salinity is 33%, increasing to 34.5%, and still deeper it reaches up to 34.8%. Generally, it can be said that the high latitude salinity increases with depth due to denser water mass found at the bottom. Oh, figure 4. Distribution of salinity into water. Check your progress. First, define the salinity of seawater. Examine the factors influencing salinity of seawater to account for differences in the distribution of salinity seawater in the world. Conclusion: the study of the ocean morphology has helped to understand the types of submarine relief features in the ocean basin. The relative importance of different oceanic relief features provided with different types of resources required either for geochemical cycle functioning or directly as resource in the form of marine organisms, minerals, and fossil fuels. The temperature balance of the Earth is largely maintained by oceanic surface as it absorbs huge amount of global heat. Salinity of oceanic water is governed by different factors. Differences in salinity cause different biodiversity results in oceanic waters besides deriving salts from seawater. 4.8%. What do you understand by morphology of ocean? 2. Explain the importance of ocean morphology. 3. Examine the distribution and location of bottom relief features of Pacific Ocean. 4. Salinity of seawater varies in different areas. Explain given reasons. 5. Account for the distribution of salinity of seawater in the world. References: 1. K. Siddhartha 2000 Oceanography, A Brief Introduction, Kisalaya Publications, New Delhi. 2. Savindra Singh 2011 Oceanography, Prayag Pustak Bhavan, Allahabad.